Hello everyone, welcome to my channel CISE Topper Classes. Today we are going to discuss M.L.aggarwal Class 9 Mathematics Chapter 15 Circle Exercise 15.1 question number 1 to 7 of this exercise. So let us start solving this exercise here in this video.
Now let us solve here chapter 15 circle. To solve it, the theorems which I am going to use frequently in this exercise, we will firstly take an introduction of that. So here the first theorem is the straight line drawn from the center of a circle to bisect a chord which is not diameter is perpendicular to the chord. Means this line from the center O, if it is perpendicular, if it bisects a chord which is not a diameter, then it is perpendicular to this chord AB. Now the theorem 2 is same as that of 1. The perpendicular to a chord, if the this line from the center is perpendicular to the chord AB, then this line from the center bisects it into bisects the chord here. Now we have theorem 3 as equal chords of a circle are equidistant from the center. Means here OM is equal to ON, because these are equal chords. AB is equal to CD given to us. From that we can just conclude that the distance from the center is equal. Now we have theorem 4. Chords of a circle that are equidistant from the center of circle are equal. Means here chords of circle that are equidistant, same as that of 3 only we can see. If they are equidistant means the chords are equal. Now we have the theorem 5th as last one. There is one and only one circle passing through given non-collinear points. If there are three non-collinear points, then only one circle can be drawn joining these 3 points. It means that 2 points can have two different circles. If two non-collinear points are there, then they can draw two different circles of different radius here. Let us solve here. First question of exercise 15.1. Here we have to calculate the length of the chord which is at a distance 12 cm from the center of circle of radius 13 cm. Means the radius of the circle is 13 cm. We have to firstly find by Pythagoras the value of AM. So we can write here by Pythagoras theorem, AM square is equal to OA square minus OM square, because Pythagoras theorem is equal to hypotenuse square is equal to base square plus height square. From that we have concluded. So in triangle, by Pythagoras theorem, in triangle OAM we have taken. So we have applied in that, and we can take here 13 whole square minus 12 whole square equal to 169 minus 144. This is equal to 25 here. We will take the under root. So AM is equal to under root 25, means 5 is the final answer. And we have to find the here length of the chord. So AB, because AM, if a line is perpendicular to the chord, means it bisects the chord into two equal parts. So we can simply take here AM is equal to MB, means here AB is equal to 2 AM. We will put the value of AM, 2 into 5 will be 10 centimeter. So this is the final answer here in this question, means the length of chord AB. Length of chord AB which we have to find in this. So this is the solution of the first question. Solve here second question. A chord of length 48 cm is drawn in a circle of radius 25 cm. This is the radius. Then calculated distance from the center of the circle, means this OM we have to find. So first, because this is a line perpendicular to AB, means it bisects AB. So we will take here by Pythagoras theorem, in triangle AMO, by Pythagoras theorem, we can simply write here AO square is equal to OM square plus AM square. Because it bisects, means AM is equal to here AB divided by 2 equal to 48 divided by 2 means 24 centimeter. We have to find the value of OM. So it will be OM square, AO square minus AM square. So it will be 25 का whole square minus 24 का whole square. So here we can subtract. So it will be 625 minus 576. So on subtracting, we will get here 49. On taking the under root, we will get 7 centimeter as the final answer. And this is only we have to find the distance from the center of the circle. So this is the final answer of the second question. Now let us solve here third question. A chord of length 8 centimeter is at a distance 3 centimeter from the center of the circle. Calculate the radius of the circle. To calculate the radius of the circle, we will take here in triangle OMB by Pythagoras theorem. We can simply here take OA square, hypotenuse square is equal to OM square plus AM square. We will put the value, so it will be OA square is equal to 3 square plus 4 ka whole square. So 9 plus 16 is equal to 25. We will take the under root, so it will be 5. So the value of radius here is 5 centimeters. So this is the final answer here in this question. Let us solve here. Fourth question. Calculate the length of the chord which is at a distance 6 centimeter from the center of circle of diameter 20 centimeter. So here diameter is 20 centimeter. So we can simply write the radius as 10 centimeter, half of the diameter here, and we have to find the length of the chord. Means in triangle OAM we can write, we have to find the value of AM, then only we can find the value of AB, the value of chord, because OM bisects the chord here, this length. So we can simply take here in triangle OAM, OA square is equal to AM square plus OM square. We will put the value here. OA square is equal to 10 ka whole square. AM square we have to find plus 6 ka whole square. So 100 minus 36 is equal to AM square. So it will be 64 equal to AM square. We will take the under root, so it will be 8. 8 is equal to AM. From that only we can find the value of AB as 2 into AM. We will put the value of AM. So 2 into 8 is equal to 16 centimeter. So this is the answer here in this question. Now let us solve here fifth question. A chord of length 16 centimeter is at a distance 6 centimeter from the center of the circle. Find the length of the chord of the same circle which is at a distance of 8 centimeter from the circle. So firstly we will find the radius of the circle, so that we can find the chord here CD. Let it be AB. Here to find the value of radius, we will take the triangle in triangle AMO, let it be M and this be N, by Pythagoras theorem. So here we have, by Pythagoras theorem we can write it as OA square is equal to OM square plus AM square. This we can write it as 6 ka whole square plus 16 ka whole square. So this is equal to 36. Sorry, here we have 8 because half of AB we have to write. So AM square is 8 square. 36 square plus 64 is equal to 100 here. And we will take the under root. So A is equal to 10 centimeter. Means the radius of the circle is 10 centimeter. From that only by Pythagoras theorem applying in triangle ONC. So in triangle we can find the value of the chord ONC. We have OC square is equal to ON square plus CN square. Simply we will find the value of CN from here. So OC is we have found, because radius of a circle remains the same. So 10 ka whole square equal to ON is 8 ka whole square plus CN square, means 100 minus 64 is equal to CN square. This we will write as 36 CN square. We will take the under root here. So 6 is equal to CN, means 6 centimeter here is the value of CN. We have to find the length of the chord CD. So here this X is equal to 2 into Cn, which is equal to CD here. So this we can write X is equal to 2 into 6. So 12 centimeter is the length of the chord CD. So this is the final answer which we have to find in this question. Now let us solve here sixth question. In a circle of radius 5 centimeter, AB and CD are two parallel chords of length 8 centimeter and 6 centimeter respectively. Calculate the distance between the chords if they are on the same side of the center. If they are on the same side, so we have to find here, this is the diagram of the same side and this is the diagram of the opposite side. Firstly, we will solve this part. We have to find the value of Mn. So to find the value of Mn, here we will take in triangle firstly OCN. So in triangle OCN, by Pythagoras theorem, we can find the value of here Mn. Sorry, On. So here it is OC square is equal to ON square plus CN square. We will put the value. So it will be 5 ka whole square equal to ON square will be, this will be ON square only, and we have to find the value of On square means minus Cn square. The value of Cn here is half of 6 means 3. So 3 ka whole square. We can write here 9 minus 25 is equal to On square. So on taking the difference here, we will get here 16 equal to On square. We will take the under root here. 4 is equal to On is the value of On here. Now, similarly in triangle OAM, we will use the Pythagoras theorem, and OA square is equal to OM square plus AM square. We have to find the value of OM square means OM square is equal to OA square minus AM square. OA square is given to us as 5 because radius is 5, and AM is, here we have AM as half of AB. So it will be 4 ka whole square means 25 minus 16 is equal to 9. We will take the under root. So OM is equal to 3 centimeter here. As OM is equal to 3 centimeter and ON is equal to 4 centimeter, we can find the value of Mn by subtracting OM minus here On minus Om. So this will be On, on putting the value of On here as 4 minus 3. This will be 1 centimeter. Means the value of Mn here is 1 centimeter. Now on solving the second part, when the chords are on the opposite side, we have to find the value of Mn again. So firstly in triangle AMO, we have OA square is equal to OM square plus AM square. Again we can write here as OM square is equal to OA square minus AM square. We have AM as half of AB, so OA square is 5 ka whole square minus 4 ka whole square. This will be 25 minus 16 equal to 9 centimeter. On taking the under root, OM is equal to 3 centimeter. Now in triangle OCN, we have OC square is equal to ON square plus CN square. We will put the value here. So OC square is 5 centimeter, 5 ka whole square equal to ON square plus CN is half of 6. This will be 3 ka whole square. From there only we can find ON as 5 whole square minus 3 whole square. This will be 25 minus 9 equal to 16 means ON is equal to 4 centimeter. Now we can simply find the value of Mn, which we have to find. Mn is equal to Om plus On in this case. So we will add 4 plus 3. This will be 7 centimeter from here. So this is the final answer in the second part, and this is the final answer in the first part. And this is the solution of the first and second part here in this question. So here this is the solution here in this question. This is the solution in this. Let's solve here seventh first part. In the figure given below, O is the center of the circle. AB and CD are two chords of the circle. OM is perpendicular to AB and ON is perpendicular to CD. AB is equal to 24 centimeter. OM is equal to 5 centimeter. ON is equal to 12 centimeter. Then find the radius of the circle. So to find the radius of the circle, we will use Pythagoras theorem. So by Pythagoras theorem, on applying in triangle here AMO, we will find here AO square is equal to AM square plus OM square. AB is given to us means if OM is perpendicular, it bisects also. So AM is equal to half of AV, that will be 12 ka whole square plus OM. OM is 5 as given in the question. So here it is 144 plus 25, this will be 169. On taking the under root, AU is equal to 13 centimeter from here. As this is the radius of the circle AO, we can simply find the value of now length of the chord CD we have to find. From this given information radius, we can simply find the value of CD here by finding in triangle here OCN by Pythagoras theorem again. We have OC square. OC square is equal to ON square plus um, Cn square. We have to find the value of Cn. So Cn square is equal to OC square minus ON square. OC is the radius, so we'll put the radius as 13 whole square minus ON. ON is given to us as 12 centimeter. We will take this square here. 169 minus 144 is equal to 25. We will take the under root. So Cn is equal to 5 from here. 5 centimeter means the double of Cn. 2 into 5 is the length of the chord CD. So 10 centimeter is the final answer in the second part, here in the seventh first part. Now let us solve here 7th second part. In the figure given below, CD is a diameter which meets the chord AB in E such that AE is equal to BE. This is equal to 4 centimeter. If C is equal to 3 centimeter, find the radius of the circle. So here because OA is perpendicular means OE bisects here. Hence BE is equal to AE. Now we will take the triangle OBE. In triangle OBE, as OC is the radius, so we can write it as whole radius, and CE is 3 centimeter here. So we can simply write the value of OE as R minus 3 centimeter, and in triangle OBE by Pythagoras theorem on applying, we can write here OB square is equal to BE square plus OE square. On putting the value here, this will be OB square equal to BE as 4 का whole square plus OE. This will be R minus 3 का whole square. Here it will be 16 plus R square plus 9 minus 6R. We can write it as R square minus 6R plus 25 OB square. OB square is also radius, so we can put the value R square here also. R will be R square will be cancelled out from here, and this will be 6R is equal to 25 here. So on dividing this, R is equal to 25 by 6, and this will be 4. 1 by 6 is the answer here in this question. Means this is the radius here.
Thank you for watching my video. If you like this video, please like, share and subscribe my channel.